Section 3.2, this is substituting numbers into a given expression or formula in order to evaluate them. In other words, find the value of that formula or expression if you're given numbers. So let's just do a very basic one here. This is question 2a. I won't do many of these, we've done loads in unit 2. I've got 30 degrees plus, gone glitchy, right, plus 2x minus 3y, and I'm told x is 15 degrees, okay then, and I'm told y is 5 degrees. Remember, we can use a calculator in this unit and find the value of each expression, okay then. Alright, so what have I got? I've got 30 degrees plus 2 lots of 15 for the x's, take away 3 lots of 5 for the y's. So what have I got then? 30 plus 2 15s are 30, 3 5s are 15, so it's minus 15. So I'm showing every step here. So 30 plus 30 is 60, take away the 15, leaves me with 45 degrees. So the final answer is 45 degrees. That's that one done. I think I'll do 2d just up here. I've got 5y minus 6x plus 112 degrees. I'm told that x is 12. I'm told that y is 32. So what have I got? Substituting these values into the x and y as shown, or the y and x, I've got 5 lots of 32, take away 6 lots of 12, and then add on 112 degrees. Let's just get the total there. 532 is 150, 160, I believe, yes. Take away 6 12s are 72, then add on 112. Because it's getting late and I'm tired, I'm going to use my calculator. So 160, take away 72, add on 112, comes to 200 degrees. Lovely. So it's 200 degrees. The context is degrees, so we use that. I think I'll do E now. E says this. I've got 360 degrees divided by 2x, and I'm told in the question x is 5 degrees, so substitute 5 in there. In other words, I've got 360 divided by 2 times 5. In other words, 360 divided by 10. In other words, 36 degrees. That's that one done. There's plenty down here to do. There's just too many, but it's so not worth it. I'm going to turn over the page. Question 7 is asking me to do more perimeters, just like in the other section. And they look a little harder though, and besides it's grade D rated, so I'll give it a go, shall I? So let's start off with, I don't know, C. It was quite complicated, so I'm going to do it. It's a pentagon by the look of it. 1, 2, 3, 4, 5. As you can see, it's beautifully drawn. This side is 2D, that side is 2D, this side is 3D over 2, in other words 1.5Ds, this side is 3D over 2, and this side is 3D divided by 2. Essentially, to work out the perimeter, I've got to add up these 1, 2, 3, 4, 5 terms, and I'm going to work down here. Hopefully there's space. So here we go, 2D plus 3D over 2 plus him as well, 3D over 2 plus him as well, 3D over 2. Let's just simplify this bit. I've got 4D so far. Now what about this? I've got 3, 6, 9. So in other words, I've got 9Ds divided by 2. What is 9 divided by 2? 4.5. So altogether, I've got 4Ds plus 4.5Ds. Altogether, I've got 4 plus 4.5. I've got 8.5 Ds altogether, and I'm happy to leave it just like that. So check again, 3, 6, 7, 8, 9. Yeah, 9D over 2. In other words, 4.5 Ds plus the other 4 Ds is 8.5 Ds. I think I'll do this one over here. It's a parallelogram. Got loads of space here, so I'm going to try and make it look like a parallelogram. Now you may recall that these lines are parallel, but then so are these as well. So I've got 2 pairs of parallel lines, hence parallelogram. This is called 7.6e, bless him. Wouldn't make it easy, would they? And this is called 5e. Now if you know it's a parallelogram, then this side is also called 5e lengthwise, and this side is parallel to the side up the top there. That's also 7.6e. Let's make it look a bit more like an e. There you go. Essentially the perimeter is going to be as follows. I've got 7.6e plus another 7.6e plus the two 5e's plus another 5e, please fit. So 7.6 and 7.6 is 14, 15.2, no calculator required for Mr. Christou. Plus 5 and 5 is 10, 10e's altogether, 15.2 plus 10, I've got 25.2 multiplied by e, and that's that one. Don't want to do any more of those. What I will do is one of these questions involving horrible little star. I'm given two rectangles and I will draw them both and then we'll get into the storyline. One of these challenging, that's called triangle, rectangle A, rectangle B, just to make life interesting. They've drawn it a little bit wonky as well. I won't do that. These two rectangles have got the same area. Oh, better write it down. Same area. Now you know how to work out the area of a rectangle. It's the length times the height, or the length times the width. Call it what you like. It's that times that. It's that times that, and they are the same. So I'm told this has got a width of x plus 1, that's that bit there, and it's got a length of x minus 1. Okay, not a problem there. And I'm told that x is 5. Oh, plenty of information there. And I've got to find the value of y. Great, so the length of this one I'm told is 2y, and the width of this one is called y minus 1. Great, so if I substitute that 5 into here, then I can work out the area of this rectangle over here, can't I? So here I go. So 5 is going to go in there, and a 5 is going to go in there. So what have I got then? So rectangle A, didn't work out very well. Rectangle A, R-E-C-T. Anyway, rectangle A is going to be, well, 5 take away 1 is 4, and 5 plus 1 is 6, so 4 times 6 is 24. Doesn't even mention centimetres. Let's assume they're in centimetres. I'm going to call that centimetre squares. It's an area, and the area of this rectangle is going to be 2y multiplied by y minus 1. Alright, and I'm not given the value of y. I've got to find the value of y. Okay, fine. They've got the same area though, so therefore I know that this area is going to be 24. If I just divide by 2 here, that gets rid of that 2 from this side, so I've got y bracket y minus 1 equals 12, because 24 divided by 2 is 12. So I've got to think of two numbers, whole numbers, where y substituting into each part of the expression gives me an answer of 12. Well, I can see quite simply, if I've got a 4 there and a 4 there, I've got 4 lots of 4 minus 1. In other words, 4 lots of 3, and that makes 12. So here's my final conclusion: y is 4. And this was in fact a bit of a trial improvement situation, but it wasn't difficult because we'd given some very simple numbers. And there you are. And I'm told in the question both x and y are whole numbers, so there's not too much guessing going on there. And I think I'll stop there. That's good enough. All we've done is substitute numbers into expressions and formulae and worked out the missing bits. We've done a couple of perimeters. There's obviously an algebra twist to this because we're playing with shapes and there's letters attached to the shapes, and we've merged shapes and algebra together, which is really nice. So I think I'll stop that one right now, and we'll move on.